And welcome back, students, to our next lesson. We're going to be talking about solid-state drives. So, getting started, a solid-state drive, or an SSD, also known as a solid-state disk, is a solid-state storage device that uses integrated circuits assemblies as memory in order to store data persistently. So this is, again, another form of non-volatile memory. Now, compared to traditional hard drives, SSDs have no moving mechanical components. This is what distinguishes them from the traditional electromagnetic magnetic disks, such as hard drives or floppy disks, which typically contain spinning disks and then those removable read-write heads that we discussed in our last lesson. Now, SSDs are typically much more resistant to physical shock, meaning like if you were to drop them, because there's no moving parts, they're going to not necessarily be as damaged. They also run more silent because, again, there's no moving parts. They have quicker access time and lower latency. And that has to do with how the architecture is set up on an SSD. Now, there are some drawbacks to SSDs. We've been talking about SSDs having some better performance, but there are some drawbacks to them. The first is that SSDs still store data in electrical charges, which, because of that very nature, leads to slow leaks over time if it's left without power. In other words, it will actually start losing data. This also causes worn-out drives, which have already passed their endurance rating, to actually start losing data. So, we've talked about how SSDs only have so many read-write cycles that they can use before they start wearing out. Once they've reached that, then they start encountering this after 1 to 2 years of storage. Because this happens, you generally don't see SSDs being used for archival purposes, storing data for the long term. You'll see either magnetic tape or a traditional hard drive. Now, when we talk about hybrids, these are hybrid drives, or the solid-state hybrid drive. These combine features of both SSDs and HDDs in the same unit. Typically, it's done by containing a large hard drive disk and an SSD cache in order to improve the performance of frequently accessed data. Now, the SSD has two main components. The first is the controller. Every SSD includes a controller that incorporates the electronics that bridge the NAND memory components to the host computer. The controller is an embedded processor that executes firmware-level code and is one of the most important factors of SSD performance. The performance of an SSD can scale with the number of parallel NAND flash chips used in the device. The other component is what's known as the memory. Now, most SSD manufacturers use non-volatile NAND flash memory in the construction of their SSDs because of the lower costs associated with DRAM and the ability to retain the data without a constant power supply, ensuring data persistence through sudden power surges. Now, flash-based memory solutions are typically packaged in standard disk drive form factors, such as 2.5-inch, 3.5-inch. Additionally, SSDs that are based on volatile memory, such as DRAM, are characterized by very fast data access, generally less than 10 microseconds, and are used to primarily accelerate applications that would otherwise be held back by the latency of flash SSDs or traditional hard drives. Now, DRAM SSDs usually incorporate either an internal battery or an external AC/DC adapter and backup storage system to ensure that data persistence occurs while no power is being supplied to the drive from external sources. Remember, because these are using volatile memory. Remember, volatile memory, once the power is lost, your data is lost. So that's why they need to have some kind of backup for the power in order to keep it pretty much in a low state that allows it to retain that information. Now, SSDs of this type are usually fitted with DRAM modules of the same type that's used in regular PCs and servers. Alright, lastly is a comparison to HDD. Making a direct comparison between solid states and hard drives can be, if not outright, difficult. This is because traditional solid state benchmarks tend to focus on the performance characteristics that are poor with traditional hard drives, such as things like rotational latency and seek time. As SSDs do not need to spin or seek to locate data, they may prove vastly superior to hard drives in such tests. However, solid states have challenges with mixed read and writes, and their performance may degrade over time, as we already talked about. Now, most of the advantages of solid-state drives or traditional hard drives are due to their ability to access data completely electronically instead of electromagnetically. which results in superior transfer speeds and mechanical ruggedness. And that concludes our notes, folks. Until next time.